go. Oh yeah, that's much better. Alright, I'm gonna mute myself here. Oh yeah, you guys can see that now. And it's broadcasting at 720p. Alright, let's go back in here to Eagle and we'll get this started. I really need 2 monitors, so if anybody happens to come into chat, if you will just bear with me, I'll check it every few minutes. Gonna have to set up something like my buddy Carrington's got. Oh yeah, while I'm doing that, let me bring that up. This coming Saturday, oh man, I just had that up. The 21st at 3 p.m. Eastern, my book reading buddy Carrington TV is going to be narrating an H.P. Lovecraft sci-fi book, while some of the members of Team Art Treat are going to be... Sorry, can't hear my husky in the background. While they're going to be drawing pictures and doing art of their favorite scenes out of the book. So that's going to be really cool. It's going to be 3 artists plus my friend Carrington TV. While he reads the book, they're going to be drawing, painting. It's going to be really cool. That's this coming Saturday, the 21st, at 3 p.m. Eastern Standard Time. Alright, so we will need to connect this up. You see I got a photocell. I've got my transistor. I got a resistor. Actually, I need 2 resistors. Let me add that really quickly. I'll just copy this one. Copy, paste, and we'll change the value on that. Nope, that's not it. Where's the button? There's the button. It's going to complain. Sorry, my husky's very noisy. Alright, so I got a 58 ohm resistor and a 10k resistor. This serial here is I'm actually using an older Uno with a removable processor. I'm using it as a serial board. Any serial adapter will work. The CH540 or the FT232, they all wire up the same. I'm not using any other pins except for the TX and the RX and power here from it. It says battery, but it's actually power from the Uno USB to serial, which is 3.3 volt, which is not listed there, which it should be. 3.3 volt. Which will just take away battery. Just say 3.3 volt. Alright, so we'll get this hooked up real quick. The 328P has a reset pin. In production, you would make sure this pin is pulled high to keep the chip out of reset. Since I'm uploading code and stuff and I don't have a button breadboarded, this pin just floats and I use a ground wire to touch it to reset it. So we'll leave that pin floating high. Pin 20, pin 7, pin 21 is all our voltages that we get a positive rail from. So we'll go up here for our 3.3 and we'll create a line. Alright, so we know this goes up here to positive, and then pin 7 can also connect here, so can pin 21. Alright, the 2 crystal pins we don't have to worry about because we are running this with the internal oscillator at 3.3 volt, so we can use it 3.3 volt. So we don't have an external crystal. Ooh, excuse me there. And then we have our grounds. I'll run our ground wire back. I know this will be kind of long, but we'll just kind of move that back here. Like I said, this is not a design day or anything, or how to show you how to design an eagle. It's just me doing a quick wire up. This is all on the breadboard, by the way, one of the mini ones. All right. As you know, the Atmega 328P is a 28-pin dip socket, dip package chip. They come in other form factors, but the easiest to use for DIY stuff is the dip package. Makes it easy to put it in a socket. You can change it if you burn one up, etc., etc. All right, we got that hooked up. Let's hook up our serial connection so we can actually talk and listen to the chip. Of course, ground is ground. I'm going to run it back here just to keep it out of the way. Voltage is, like I said, it's the same from here, which is 3.3. Since technically it's coming from there, this is going to be kind of backwards, but and it might help if I select the right one. All right, and let me verify something just real quick here. One second. I think I ran into a issue here. I just want to make sure that I'm not telling everybody wrong. Again, I'll link or I'll add them in post production here of how to set this up. Now, normally, here's something that's different on mine that you'll run into is, just make sure this is still right. Yeah. Is when you're hooking up a serial converter, a USB serial converter, normally you swap the pins, like the TX, the outgoing from the chip goes to the incoming of the serial, vice versa. But when you're using it the way I am with an older Arduino board, it's a straight connection. It's receive to receive, TX to TX, because internally on the Arduino board they've already done the swap, so you don't have to do it here. So normally this would be swapped, like, okay, you got the receive line RX, this would go to the transmit of the chip. But for my setup, it's different. It's receive to receive and transmit to transmit. So your mileage may vary with that. These will make sure everybody can see them. All right. And that's the only two you need there. And that gives you communication. Like I said, for the ground, to reset the chip, I just have a ground wire floating that I just touched the pin with on the breadboard. Okay, next thing will be to wire up the temperature sensor. For the SI 7021, pin 1 is positive. Actually, you know what? I messed that up. Let's not hook that up yet. Let's hook up the transistor. Okay, transistor is an NPN style. On the screen here it says 1N2222. I'm actually using the BC337, which is just very similar to this one here. So this is the one that was in the parts list. Okay, we're actually going to move this over here a little ways so that it's over here out of the way. Okay, you want to limit the current, the Arduino, sorry, I keep saying Arduino, the Atmega 328P microprocessor can put out about 40 milliamps to each general purpose I/O pins. So you want to limit the current that it can pull, because the transistor itself can pull a little more current than the Arduino, the Atmega chip can handle. So we're going to go with a 58 ohm resistor. Anything up to about 120 ohm would work. I don't have the thing in front of me to do the calculation, but we'll just say 58 ohm for right now. Alright, we'll move that down here. We're going to put this on digital pin 7, which is pin 13. Pin 13. So we'll go over here, draw a wire. And look at that, I actually got it in line. That's really interesting. Alright, and then the collector and the emitter. The collector will actually go to positive, the 3.3 volt. So we'll grab it and draw a line over here to the positive. Again, I'm not making this look pretty for anyone. It's just, easy for me to do. Alright, so what happens is when you apply voltage on an NPN is it takes a positive voltage to saturate the transistor so that the collector will pass through to the emitter, which we're going to use basically just as a switch. You apply power here, and it allows voltage to flow through here. Alright. Next we'll hook up is the photocell. Like I said, we're going to do a comparison. The analog pins on the Mega 328 have a range from 0 volt to 5 volt, which is 0 to 1023. Most common is a 10K resistor, and that roughly gives you that that range of 0 to 1023 being full. So we're going to set that up with a 10K resistor. The 10K resistor goes to ground. Then the 10K resistor to the photocell. So that will be drawn out like this. Do I need to move this, I wonder? Yeah, I probably should move it out here. Yeah, we'll put it like right here, let's say. Actually, let me rotate it here. There we go. Alright, we're going to bring the 10K resistor down here and get the right tool selected here. Alright, we're going to grab our line. We're going to go to ground. From the resistor up here to ground. As you can see, I kind of got that thing in the way. We'll move it down here. Well, nope. Aha, there we go. I'm going to rotate this so it's in a good spot for us. Alright, here we go. Now, how you measure what the LDR is seeing is you put a tap off to your analog pin between the resistor and the photocell. And so I'm going to move the photocell out just a little bit more. Is we're going to connect the photocell to the resistor. Okay. And in this center point here, we want to take it off to our analog pin, which we're going to use analog 0, which is pin 23. Actually, let me make sure that's right. Way I've got it on my breadboard here. Let's see, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah. All right, pin 23. All right, which is the top pin here in our schematic. Okay. So we'll take a line off of here, come down here. Like I said, it's not elegant, and we want to tap that center point there. Okay, then the other side of the photocell, we're going to run down to our transistor because I want to be able to turn the power on and off. So we'll grab a line, come down, and come across and connect to the transistor. Alright, and then the last thing we have to hook up is the temperature sensor. There's not a package or device in Eagle for it. I want to create one myself. I'll get there. So right now I'm just using a plain header with pins 1 through 4. Pin 1 on the SI7021 is power. So again, we want to be able to turn that power on and off. So we can actually just drop down here and clip onto this power that powers the photocell because it runs through the transistor. So when this pin is low, these two are turned off. They have no power coming to them. Okay, pin 2 is ground. And my whiny husky is whining again. He's always whiny. Pin 2 is ground, so we'll just go to ground. Like I said, this is an I2C chip, I2C bus chip, so it actually connects to the SCL and SDA lines, which are pin 24 and 27 and 28. Sorry about that. I had to think about that. SDA is 27. 28 is SDL. So 3 is SDL. So that's the last pin, which is pin 28. So we'll sneak over here and connect into pin 28. Alright, and then pin 4 is SDA, which connects right here to pin 27. Alright, that gives us our hookup. Like I said, this is completely set up on a breadboard. The serial connection and power are coming from an Arduino Uno with the processor removed, just using the onboard USB to serial connection. Excuse me. The power for the temperature sensor and the photocell are running through a transistor. The 1N2222, or like I'm using, is the BC337. Current limited with a 58 ohm resistor. Photocell is done as a voltage divider setup with a 10K resistor. I'll link all the how-tos that I've learned from in the description below and on the website at shadowtronics.org. Oh, excuse me. Alright, let me get a drink of water here. Well, I tried to here. There's a bottle of water. We'll take a quick second to look over and see if anybody's in the chat. Nope, no one's in chat, so we'll continue on. Alright, now that we got our schematic drawn up, and I'm hoping everybody can understand that. I know it's a little just kind of scattered brain across the screen there. There we go, make it a little bigger. Let's see how that looks. Oh yeah, much easier to read. Alright, whoops. Got a little bit of junky stuff on the screen there. Alright, like I said, I hope you can understand that. I will put a picture of this up on the website, shadowtronics.org, so you can take a look at it. And like I said, I have all this set up on the breadboard. I went ahead and already loaded a test program just to say hello world, just to make sure the chip was booting up and serial communication was working. So let me transition over to that screen and we will see what happens. All right, so I hit transition here. Aha, there we go. And as everybody knows, I am still really new at this, and for some reason I'm not getting. Let me clear that. Maybe that'll help. Let's see. Did that? Why is that not clearing? Why are y'all not seeing that? Okay, something's wrong here. Alright, give me just 1 second. Apparently it's crashed that window. Window capture. New. Okay. For some reason, that has decided not to work. Okay. Now we'll do window capture. Alright, there we go. We'll drag that over here. Transition that on. There we go. Now you guys should be able to see that it's working, hopefully. Yep, there we go. I'm going to clear the window, and I'm going to actually put the chip into reset. I'm going to clear it, and you guys will be able to see it boot up and start saying hello world. There we go. Alright, and it's just going to sit there. I got it in the loop to just keep saying hello world. Alright, I'm going to minimize that and get it off the screen so we can see the full IDE window. So we're going to transition that off the screen. There we go. And I am actually going to make the text a little bigger. Well, normally that works, but it's not working today. Tools, preferences. So we're going to go up 2 more, just for my eyes. We'll see how that looks on the screen. Okay, yeah, y'all guys can see that really good. Okay, so the first things we want to do is we start out with a blank sketch, and we want to include the 2 libraries we need. The first one is the wire library, which is for the I2C data bus, and the second one we need is the SI7021 library. The one I am using comes from, it's actually a little bit of an older one. Let me bring it up here. I'll put a link to it in the description below and on the website. But the gentleman who wrote it was Marcus Sorsen. Maybe I'm saying that right. I hope. It's copyright 2014. It was updated July 16, 2015 by a Tom WS01. To get a hold of Marcus, the email in the header file says marcus@electron14.com. And like I said, I will have a link to the GitHub page. I was looking to see if the website was there, but I'm not seeing it at the moment. So like I said, I will put that in the links below. The library works really, really well. I had no problems using it. I've even customized it a little bit for my own use, which I'll put a link to that also on the website and in the description below. Alright, so we include those. I'm not going to go in and installing libraries in Arduino's IDE or anything. There's tons of videos on that. I will be doing one of my own, but just not today. Alright, so we have a blank sketch with two includes in it. What do we need next? Alright. For the SI7021, we need a constructor, which I'm going to cheat a little bit here and grab one out of the example that comes with the library as soon as I find it. There we go. Again, I'll have more tutorials later on. Okay, so we need a constructor for the library, which is simple as just doing SI7021 and putting a name, giving it a name. I'm going to name it, instead of just sensor, since we do have several different ones, I'm just going to call it temp sensor. And everything I do, I'll reference back to that. Like to start it up, you type in .begin, which will be temp sensor .begin. We don't have any variables or anything to deal with at the moment. We will actually have some. Let me go ahead and set them up while I'm thinking about it. We're going to need somewhere to store our temperature temporarily from the sensor. And so we're actually going to need a integer and a float, and I'll tell you why we need two of those in just a moment. You actually may only need one, and we may try that here in a few minutes to see how that works. Anyway, we need an integer, to hold the temperature and the humidity. So what we're going to do is we're going to type in init for integer, and we're going to name it temperature, T-E-M-P-E-R-T-H. Is that right? No, that's not right. Is that right? Okay, yeah, guys, I'm not the best at spelling, so don't laugh at me here. A-T-U-R-E. I was close. Okay, we always fill it in with a 0, just as a placeholder until you call to fill that integer. Okay, we're gonna need a float for our decimal place. This is not technically needed, but just because I like having two decimal places. Floats by default have 2 decimal places, so we're going to call this float, and we're just going to name this temp. Again, we're going to just set a 0 placeholder, and then we need an integer for the humidity, so we'll call this int and humidity. Humidity. Alright, about to make a mistake there. Alright. There is our variables that we need. I'm trying to think if there's anything else we need in there. I don't think there is. Okay. Alright, now we'll move down to setup. Of course, we want to start the serial connection for the chip so it can post stuff out, via serial so we can look at it. So we're going to do serial.begin, and the baud rate we're using, just because everything else I have uses it, is 115200. Alright, next we need to set some pin modes, and actually I'll go up here and do this just to show you guys you do it. You can name pins, which is really nice, makes things a little more human readable, and you do that with a declare. I'm just making sure that I'm telling you guys right everything I do here. just because I have a tendency to either skip over things or just do them and not realize what I'm doing. um, Give me just 1 second to open this other file here. And I'm really working on, guys, for the live stuff in my videos. Oh, excuse me again. Trying to be a little more organized and having all this stuff ready to go. Alright, so we want to do a defines up here. Lets us name pins or associate a name with a pin. So what we're going to do is we're going to do a hash define, and then the name, we'll call this power pin, or actually we'll call it power switch. We'll call it switch because that's what it is. Well, it is power, so power switch. Okay, and then the next argument is what pin it is, and ours is going to be pin 7. Digital, well, I should say digital pin 7. And I believe that's all we have to do for that, and that's the only one we really need to name. Let me just look in here and make sure. Yep. Okay, well, we can name the LDR pin, which would be easy to remember. We'll just do define LDR pin. LDR pin, and then that is pin A0. Capitalization, stuff like that, that's all user preference. Trying to think. I like to put spaces between things just to make them a little more editable or readable. Another thing that I will stress, and I have a problem with this because I hate doing documentation, is to have some text documentation text. You can put notes in your files to make sure that the IDE doesn't think they're part of the program. You use // and then I can make comments like say // this is the transistor, and the compiler will actually ignore anything after the //. Like I said, I have a real bad habit of not doing documentation, and I've got to get back into doing that. And I stress it with everybody I teach is do documentation, because after you've slept the next day, you're not going to remember half of what you did, and you'll spend half your time scrolling back trying to figure out what you did. When you have the documentation right there, makes it a little bit easier. Alright, for the sake of this, I won't do much. I will go back and do it, and when I post this up on the website, so people will have a reference. Alright, we're back in our setup now between the two curly brackets. We've started our serial. The next thing, I like to delay just for about 10 microseconds here to allow the serial to come up. And so that's a delay. And you put it in microseconds. 1,000 microseconds is 1 second. Really don't need that long. I just like doing like maybe a 10 microsecond delay, and then I like to print out a little message to let me know that the chip is booting up and is doing the setup. So we'll do a serial dot print ln, which tells it to print a line and then create a new line after it so that there's a space. Again, open bracket. To do plain text, you do quotation mark, and then we're going to say, we're going to call this breadboard test is booting. Close bracket and semicolon. Alright, everything in the Arduino IDE, every line of code ends with a semicolon. My wife's out there chasing my husky around with a weed eater. That's going to be interesting. Alright, so the next thing we need to do, we need to set up our pins with the pin mode command. We don't have to worry about the I2C. We'll handle that in just a moment. But we do need to set the LDR pin. Since it is an input, since we're going to be reading from it, we need to set it up as an input. So to do that, we do pin mode. And then since we named it, we don't have to actually put the pin number. You can put A0 like that. Or since we named it, and we know what we named it, LDR pin. There we are. And what it'll do is when it compiles, it'll see LDR pin. It'll go back to the top. Okay, LDR pin is actually A0, and it'll change it for you. And it just makes it read, makes it human readable a lot better. All right, so we're gonna call that as an input. Okay, our pin that our transistor on a power pin, that's actually an output. And so, again, we'll just do pin mode. And then since we named it, power switch. And change it to an output. Alright, now that one is set as an output, we can actually set it low or high. Now we know that our transistor is an NPN, which means it needs power on the base to switch. So we need to write that pin high to turn the power on to our temperature sensor and the LDR pin. You complete that with a digital write command. And so we're going to go ahead and do that now in the setup so that powers everything up. We're going to do digital, D-I-G-I-T, write, open bracket, and then again, since we named it, all we have to do is type in the name again, power switch, and then we want to write it high to send 3.3 volt out to that pin to turn on the transistor. Whoops. Okay, I'm going to write in a delay here. I don't know if we actually need it. I noticed it helped before when I was doing testing. I'm going to write in a delay of 1 second. Just to give it time for the SI to set power up, set up its communication, all that good stuff. So we're going to go delay. And obviously you don't want a ton of delays in your program because it just slows it down and can cause issues if you have other things going on. If you delay for this, something else might be waiting and then it crashes. More on that later. So we're going to do delay of 1000. Okay. And then after that 1 second delay, we're going to initialize the temperature sensor so that it should be powered up, ready to go. We do that by calling the SI7021 by the name that we had set, which was temp sensor dot begin. What that does is it initializes the I2C bus and starts talking with this temperature sensor, if it's there. There are some commands you can run to verify that the sensor is there. I'm not going to get into all that. It's more advanced stuff. We're just going to call it like it is. One thing with this library is if you call this command and the sensor's unplugged or a faulty wire, it will hang the processor. There are other libraries that don't do that. I don't have them right now because I'm on a new machine. But like I said, we won't worry with that today. Just because I can check it with a multimeter if I have to. Okay. We'll call the temperature sensor, and then we'll start it up. And I think that's about it for setup. I'll put in one last thing here. I'll do another serial print just so we know we're at the end of the setup. And again, that's serial.println for new line. And then we'll say setup complete. Going to loop. Again, like I said, this is just for more diagnostics and human readability. Alright, and then you close setup with a closed curly bracket. And we're off to our loop. So we want to... The LDR is an analog signal, and we want to read that analog signal. So we'll do that the first thing in our loop is we'll have it actually go and aha. See, I about forgot. And I called it. We need a variable up here to hold our light sensor reading. You can do it inline in the loop, but again, that's another topic of global variables versus local variables. But we'll just do a global variable, which is at the top here, anything before setup. And we'll just make one that says init light level. I hope I spelled that right. And again, we'll put a 0 placeholder. Alright, so to get our reading from the analog pin, we use a command called analog read. Again, since we named the pin, we don't have to use the pin number, and so we're gonna name that. Sorry about that. I just got a piece of metal in my hand. We're gonna do analog read. Open bracket. Oh, actually, what's really cool about I don't know if that's a part of the C++ or if that's unique to Arduino's IDE, is you can update a variable with a command, which is really neat. So we know our variable is light level, right? Yeah, I had to go back and look just to make sure. So we can call light level equals the command analog read, because we want to read the analog value, and we want to read the analog value of pin A0, which we named LDR pin. So we can do LDR pin, close bracket, like that. And then what that does is every time it comes to loop around, it will update the integer light level on the value of whatever the analog read comes back as. Okay, and then what we can do is we can print that to the serial monitor, which we'll just do serial dot print ln. Actually, we're going to do print and not do a new line, and we'll make it a little more human readable by doing this. We'll make a statement: the current light level is, and then we'll put a space, because you know everything is counted. Space is an actual ASCII character, and then we'll close the quotations and close the bracket. And since we didn't print a new line, the next line we print will be right after the word is, and we want that to be serial dot print. And because we do want a new line after it prints the number, whatever the value of light level is, we'll do print ln, so it prints a new line, and then all we have to do is tell it to print the light level integer like this. Alright, so right now it'll sit there in a loop and it will flood, you know, it'll go crazy and print, it'll flood the screen with whatever the light level is. We really should test this. So we want to slow it down. So I'm going to put a delay of, I don't know, let's say every 5 seconds. So that'll be 5,000 microseconds. So we're going to go delay 5,000. Okay, we're going to test this code right now to make sure that I got everything wired up right, and I don't look like an idiot on camera, or I might. We'll see how it goes. Okay, I am actually going to comment out the temp sensor begin, just so that it's not trying to use it and I don't have the rest of the code root. So we're going to comment that out with the 2 forward slashes so that the ID ignores it, and we'll verify our code. The IDE has a really nice thing that you can actually check your code to make sure everything is right before you try to upload it. That's this little check mark here. It says verify. Let me make sure y'all are seeing this. Yeah. Oh. Hey, Soko. I didn't realize you were here. I hope you're still here. I didn't mean to miss you there. I really should have cleared the chat. Nope, you're not here no more. Or if you're online. Yeah. It says you are. Well, now I don't know if that was sent today or not. I don't know if that clears it for everyone or it'll clear it for me. Okay, sorry about that. Got a little sidetracked. Just make sure you guys can see. We're at the top of the screen. Why are we at the top? That's not where I'm at, I don't think. Oh, yes, we are. Okay, so it did scroll. Good deal. Alright. The top left of the screen here, you'll see the little verify button. We can hit that. The Arduino ID makes you save. If you wrote a new file and you haven't saved it, before it'll verify or compile the code, it makes you save. It's pretty nice that it does create its own folder for every program you write, which is really nice. So we're going to call this breadboard test 418 18. Give me just 1 second. I'll be right back. I'm going to turn a fan up here. It's getting a little warm today. Okay, I'm back, guys. We'll save that, and it will actually go in and compile the program, and just verify that I've got all the syntax right, and I haven't missed a semicolon or anything. And wow, I actually got it done right. Hooray me! That's unusual. What's really neat is it shows you how much space your program's going to take up on the microcontroller and how much memory you're using. The Atmega 328P has 30,720 bytes of program space. That's with the bootloader. There's a little bit more if you don't use a bootloader, but that's another whole nother topic, a whole nother video. And we're using 415 bytes of dynamic memory, which I didn't realize he was back in. Trivial, I mean, it's very little. So it compiled complete, didn't give no errors, so we're going to upload it and see what happens. You do that by clicking the upload button here. If you're using an Arduino board like the Uno or Mega, it'll do everything for you. You just click it and it'll go. But since I'm using it on a breadboard with a serial converter, and like I said, I don't have the reset hooked up, so I have to manually reset the chip, which is just me taking a wire from ground and touching it to pin 1 that holds it in reset. When it goes to try to upload to the chip, I remove that wire. So we're going to click upload, and this should take just a second. And if I time it just right, hey, there we go. It's writing to the chip, as you've seen. All right, it said it wrote it and verified it, and we got a thank you. So in OBS, I'll bring the window back up. And hopefully it's the right window. Alright, the light level is 0 apparently. That's not right. Oh, wait a minute. It would help if I had it hooked up. That is my fault. There we go. Now we have light level. If I clear that, there we go. You see it's running about showing 393, 388 or so. If I turn my light off here in my desk, it should go lower because the light's lower. Oh yeah, big difference. As you can see there, it went from 390s down to 77, 78. It'll bounce around a little bit because my monitor light, and it's kind of light outside. So we'll turn that back on. And you see as I turn the light back on, the number went up. So the LDR is working. So that's a very good thing. Our next goal will be to get the temperature sensor working. So I will... Oh, you know what? I'm sorry. It's not even on the screen. Now you guys can see it. Let me clear it. And we'll do this again. There we go. Yeah, I can't believe I didn't do that for you guys. I feel dumb now. I thought I had done hit transition, but I didn't. But there we go. You can see the light level. I'm going to turn the light out again, and you'll see it drop again. There we go. And you see the light level drop to 53. 56. It'll bounce around a little bit because I've got daylight here. You can change the value of the resistor from 10K to something different to get a different range, a high range or a low range, depending on what you're doing. If you want to know for sure when it's light, you can I think raise the resistor value. If you want to know more when it's on the darker side, you lower the value. I'll have to link a tutorial in from Adafruit. They do a great one. SparkFun does one also on using LDRs. For me, I know dark is anything below 50 using a 10K resistor, and light is 300s, 200 and above. And for the project I'm working on with this, I need to know absolute dark and absolute light. So, long as it's changing variables is all I need to know. But yeah, the LDR is working, and it worked the first time when I plugged it up. So that's cool. That means the transistor's working and everything. Sorry guys, I'm a little bit amazed here that it all worked the first time. So let's jump into getting the temperature sensor going. Let me go over here to OBS. Let me hide this window and transition out of it. There we go. OBS didn't crash. That's a good thing. Let me get the window open here. And my whiny husky is back. He's wanting his mommy to do, wanting my wife to do something. I think she's got him a little spoiled. That's the biggest thing. All right, now that we've got our temperature sensor hooked up, it's hooked up and ready to go. We'll re-enable that in the setup, and we'll go down the loop and I'm sorry guys, he's just being really funny. Hang on just a second. Okay guys, I'm back. Sorry about that. I had to talk to the husky to make him happy. Alright, so our commands for the temperature sensor are actually really easy. I'm just going to paste them in instead of trying to read the file to you. But it's really, really easy. Like I said, it's stored, it comes in as an integer. Which we've already set for, is called temperature, and the command is get. You can do Celsius or Fahrenheit, depending on where you're at in the world. It's done in one. It comes in as 1/100ths, which means 3 decimal places. But because it's pulled as an integer, integers are. They don't have, they're whole numbers, they don't have decimal points, and that's why we needed that float earlier. And I'll show you. I'm using that. Do you need it? Hang on just one second. There's that, and then the cord is in the Xbox. That's okay. Just pull that cord out. No, you're fine. Alright, so the first thing we want to do, we want to update our integer with the current temperature from this from the reading from the sensor. So we'll paste that command in, and as you can see, I'd actually copy the Celsius temperature, the command. I've got to go back and change it to Fahrenheit, and I need to change what we called it up top there, which is temp sensor. Hang on just a second. I'll take a swig of drink here. Okay, and we're going to change this to Fahrenheit, and of course I can't spell that because, yeah, it's me, I just can't spell it. But luckily, if most libraries, if you open the .h file, the header file that comes with the library, all the commands are listed, which they are here. I don't have this set up in OBS, so you guys can't see this. Let's see, I can probably do it really quickly here. Let's see if it'll let me do it. Window capture. Yeah, actually it did. Let me transition that on. You guys now can see it. This is the .h file, the header file, and as you can see there, I've got the command that we need, get Fahrenheit hundredths, which is an integer, and that's all we need. And we'll also need the get humidity percentage, but we'll get that in just a second. So we'll turn that off and transition back so you can see what I'm doing. I'm not sure what there we go. Alright, so this updates our integer of temperature equals whatever the sensor returns back. Okay, now that we know it comes in, like I said, it's an integer, and we know that I forgot what I was going to say. Slipped my mind. It's hundredths, so let's say 73 degrees would be 73,000. Okay, well, if we divide by 100, it will give us 73.00. So we can do just a simple math equation and have it update our float, which is simple of just doing the same command like here. And this is the reason we have this up here, temp. So all we want to do is do temp equals our temperature integer divided by 100. Now the program knows that temp is a float, so that when it updates it, it will have the decimal place for us. And then all we have to do is print out the float temp to the serial to see what it is. Again, we'll make it a little more human readable, and we'll do serial dot print the current temp in Fahrenheit is. Again, we'll leave a space, and then we'll close it, and then we'll return again, and then we'll serial dot println new line temp, our float, and that's all we need to get the temperature. What we'll do is we'll wait let's go 2 seconds and do the humidity. So we'll delay 2 seconds. Oops, not 2/100ths of a second. 2 seconds. And then we need to pull the humidity. So We have our integer up there for humidity, so we want to update it with again with whatever comes from the sensor. So this will be humidity, humidity equals temp sensor dot get, whoops, get my fingers right on the keyboard here, that's all wrong. Temp sensor dot get humidity. I may have to check. Oh yeah, it's get humidity percent, I believe. Let me check the file here. Yeah, percent with a capital P. Just like that. Alrighty, and let me erase that so we don't get confused of what we were doing there. Alright, and because it's just a basic integer, we don't have to change it, do any math with it or anything. And again, we'll just serial print it out to the console, and we'll do it again. Like I said, make it a little human readable, make it nice, look on the screen. You don't have to do this. You could print just the numbers right to the screen or out the serial terminal. But, you know, for our demonstration, we'll add a little flair to it. So we'll do serial.print the current humidity. I'm going to show you a little trick here. Level is, again, leaving that space. Okay, and now what I'm going to do is, instead of doing a new line like I did with temperature in the other one, we're going to do another inline. Serial.print open, and we're going to print our integer of humidity. Oh, whoops. So I'm about to make a mistake. And then I will print a new line after that with a percent sign. Now we can do plain text, or you can use ASCII code if you prefer. It doesn't really matter there. Alright, and then we will wait. We'll wait another 5 seconds just to let everything kind of update. So we will delay 5 seconds. And that's it. And then it'll just go back at the top and start again. It'll read the LDR, print the light level, wait 5 seconds. It'll print the temperature. Oh. Actually, I'm going to update this. Instead of having to say this way, we're going to have is space temp and then serial dot print ln. And you can even, if you know this, if you know the ASCII character, you could even put the little degrees symbol. But we're not going to get into all that today. We're just wanting to see if this works. All right, so everything looks good. Like I said, you can always verify it to make sure that it's right. Or to make sure your syntax is correct. You know, you can have correct. You can write a program and it show right and still be wrong. But it compiled okay, so we'll go up here and I'm gonna well, I'll upload it, then I'll bring the serial console up. Again, I will put the chip into reset. try to here. If I could see. Alright, and then we'll click the go or upload button. It'll compile it. And it should upload. Yep, there it goes. It's uploading. And it completed. And you see our program got a little bit bigger. Went from 3K to 5.8, almost 6,000 kilobytes. So, yeah, it went up there. Still plenty of room on the microprocessor. All right, here comes our big show and tell here. I'm gonna actually look at it before I give it to y'all. And you know what, guys? This thing's gonna make me be a liar. Because it's working. Why it doesn't work? Why it didn't work on my circuit board? I have no clue. Yeah, so it's making a butt out of me right now. Nope, that's not the right one. That's the right one. We'll transition that. And I'm gonna clear and reset the chip so we can watch it do a complete boot up here. Yeah, I can't believe this is making a butt out of me that it's actually working. Okay, so we'll clear. Okay, I've got the chip held in reset, so I'm gonna let the chip boot up and we'll see what it does. Okay, the light level's working and the temperature's working. Okay, that was really weird. Okay, I must have had something miswired and wow. Okay, so I don't know what happened there, but it's working. Yeah. That's making a butt out of me. And as you can see, it's about 75 degrees here in my here at my desk. That's fairly well accurate. I'm trying to see where the sensor's at. There it is. It's kind of floating in midair here, and I've got a fan on. And the light level's bouncing around because it's on the breadboard, and actually there's wires covering it, so the light's not getting all the way through. But as you see, guys, it works. Not sure why it wouldn't work before on my circuit board I made, but hey, at least I got it to work. Wow. This wow is about all I can say at the moment because I couldn't get it to work any other way. But it works. I hope you guys found this interesting. I'm going to do a little more testing here. You know what? I'll record it. One of the other problems I was having is, well, this is not a complete reproduction of the test situation, which I'm getting ready to do. Is when I was testing my homemade circuit board, I was not using the LDR whatsoever, and the temperature sensor wouldn't work. And so I am going to comment out everything for the LDR to make it like it's not even there, but it's there physically, and see what happens. So what we're going to do is we're going to turn off this pin mode, and then we're going to turn off this, and this. Okay, that way it doesn't even know that there is an LDR. The define can stay there, but you know what, I'll even comment it out, and I'll comment out that too. Okay, so that makes it look like that the LDR it doesn't even exist. We'll put the chip into reset, and we'll upload. yeah, sorry about that, guys. Had a message from a friend of mine. Make sure Chris is on. Okay, it uploaded, so let's see what it's doing. And it's probably gonna make a butt out of me. I have a feeling. Yeah, it is. Okay, so that leads to tell me that, yeah, apparently I had something wrong in my drawing, in my schematic. Well, that's the whole point of prototyping and doing it DIY, especially prototyping. Sorry, a buddy of mine just sent me a funny message. Oh jeez. Okay. Yeah, so this is working, which leads me to believe I must have had something wrong. But now we know. And that's actually about right. I think that's what it's showing here in the house on the home thermometer, or thermostat, I should say. But I hope you guys like this. Stayed along with me for, I don't know how long this video is, but let's see. About an hour. That's what I wanted to run it at. It's about an hour, so I did good. Sorry, getting messages and it's distracting me. Thanks for hanging out with me. If you got this far with me for an hour, I hope I didn't bore anybody to death. Anyway, check out the website, shadowtronics.org. Click follow, like, subscribe, hit that bell, you know, the whole YouTube thing. And I hope to hear from you. And so if you have any questions, comments, tips, tricks, check it out. Again, if you like books, like sci-fi, fantasy, Dracula, old books, check out my friend Carrington TV. He does 5 nights a week. Live cold reading of books. It's really good. It's a live audio book. It's really good. And again, a special thing going out this Saturday, the 21st at 3 p.m. Eastern Standard Time, is the group team art treat. And Mr. Carrington TV, he's going to be narrating a H.P. Lovecraft book, while 3 artists from that group are going to draw and paint scenes from the book. So if you like art, art, drawing, book reading, come by and check it out on his channel. It's mixer.com/Carrington TV, or you can catch it on mine because I'm going to host it hopefully. It's mixer.com/Shadow Towing. A lot of people ask me what is Shadow Towing. I used to have a towing business and that was the name. So I kind of set it for my Xbox name, and it's just kind of followed me over to Mixer. But my name's William. I'm glad you guys stopped by to check this out. And hope you have a blessed day. And come back and check us out. And again, our website is shadowtronics.org. And we'll catch you next time.